Hello students, welcome to the new session of vector calculus. So in this lecture we will discuss about physical quantities, vectors, scalars, scalar quantities, vector quantities and representation of vector and so many things. So students, first let us know what is physical quantities. The physical quantities are the quantity which can be measurable directly or indirectly. It's called physical quantities. Okay, so physical quantities are of two types: scalar quantities and vector quantities. So scalar quantities are the quantities which has only magnitude in terms of specific unit, and vector quantity which has both magnitude and direction. Let me first show you what is scalar quantity first. Here you can say, guys, here I have a marker, right? Here, so I can measure the length, right? I can measure the length. Here let me show you. Okay, so this is 13 centimeter, so I can write the length of this marker is 13 centimeter, right? So this 13 centimeter is called the scalar quantities. And let me show you the vector quantities. For example, here east, west, north and south. I have done a direction map. Here it is a let us consider this is a constant body. I am placing this. Okay, now I apply the force on it, on the constant body, towards the north direction. Then I can say there is an existence of force, and it can be written as F upon rho. Okay, then we have both magnitude and direction here, as you have seen. And here I can say here is an example of scalar quantities, that's mass, length, area, volume, time, speed, etc. So these are the example of scalar quantities. And the vector quantities examples are force, displacement, velocity, momentum, acceleration, etc, etc. Okay students, so students, now we will discuss representation of vector. So it's a directed line segment. Okay, look, as I have done here, look, F upon rho, and this is the vector, right? This is the vector. And if I draw this one with the initial point and the terminal point, this one is the terminal point. As you can see, there is an arrow right on the right side. So this is an initial point, and this is called the terminal point, right? This is the initial and this is the terminal point. If I place this one A, here is B, then I can say AB upon rho is the vector. And there is some examples like A vector, V vector, C vector, R vector, P vector are also the examples of vectors, right? As you can see, I have done all this with initial point, terminal point, PQ, and symbolically it is written V upon rho. This is PQ vectors. Okay, so students, there is an important note, please note it down. If we will magnitude the vectors, then we will get the scalar here. Okay, so AB upon rho, the magnitude of AB upon rho is equals to A rho, as you can see here, AB, right? So this is a vector and it's written as A upon rho. Then AV vector magnitude is equals to A vector magnitude is equals to A. So that means when we magnitude a vector quantity, we get the scalar quantities. Now students, we will discuss the types of vectors. So there are so many types of vectors. First we will discuss about zero vector. Students, see, if I place a point here, then if I ask you a question, what is the initial and terminal point of this point? So what will be your answer? So your answer will be the initial point and the terminal point will be the same, because here we have a point. If I place A here, then I can say the initial point and the terminal point is same, so this can be written as a vector, right? And the definition is a line started from a point A and it will not move any direction, and this can be represented as a vector, b vector, c vector, etc. And symbolically this can be written as zero vector, and in some other word we also called as null vector. Okay, now students, move to the second vector, that is the unit vector. The vector whose magnitude will be 1 is called unit vector. Okay, that means unit vector along a of an arrow is equals to a cap, right? So the magnitude a of an arrow, that means a vector magnitude, is equals to 1 is the unit vector. Now discussing about co-initial vector. Co-initial vector, that means the vector starting from a single point, that is if I place a point here named as O, then there is some vector, there is 3 vector starting from the same point, that is here is the point O, and the vector will be OA, OB, OC are represented vector starting from one point O. So OA, OB, OC are called co-initial vector. Now students, discussing about collinear vector, as you can see here there is 3 vector, A vector, B vector and C vector. When 3 vectors are parallel, then this is called collinear vector, right? A vector, B vector, C vector, these are parallel. But sometimes what happen, there is a vector, sometimes they have opposite direction, right? This vector from west to east direction, and this is east to west direction. Okay, so now students, move to the second one, that is equal vector. Equal vectors. So equal vectors means when 2 vectors are equal, that means 2 vectors have same magnitude and same direction. That means if I take an example here, A vector and B vectors, both the vectors have same magnitude and same direction. That means we can say, so 2 vectors are equal, that is A vector is equals to B vector, is called equal vectors. Okay students, so now we will discuss about negative vectors. So as you can see, the vectors, there is 2 vector, AV vector, but the arrow is different here. As you can see, this is west to east and the arrow is towards east direction, and here the arrow is towards west direction. So in negative vectors only the direction changes. That means I can say AB, positively AV vector is equals to minus of BA vector. That means from east to west direction I can say AV vector is equals to minus of BA vector, but the magnitude is same. The magnitude of 2 vector will be same. Now students, discussing about line of support, the line of infinite length on which the given vector lie is called line of support, or simply support of that vector. That means the length of the line, as you can see that this is a dotted line. Okay, so the length of this line is infinite, and the AV vector places here, so this is called line of support, right? Okay, so here we will discuss our sense of a vector. Let A be a vector, that means a vector from A to V, and if V a vector is a vector, that means the vector from V to A, then both the vector will not be same. Okay, so I can say the vector from west to east direction and the vector from east to west direction will not be the same. That is the sense. Look here, skew vectors which are not coplanar. The vectors which are not coplanar is called skew vector. Students, here we discuss like vector. The vectors are said to be like vector if they have same direction. As you can see here, there is 4 vectors: A vector, B vector, C vector and D vector. Every vector have same direction. So these vectors are called like vector. And unlike vectors are the vectors which has opposite direction. Here is 2 vector I have done, A vector, B vector, right? So A vector has the direction from west to east and B vector has the direction from east to west. So they have opposite direction, so I can say these 2 vectors are unlike vectors. Here is an important note. Look, okay, so note, magnitude does not require to be same in like unlike vectors. Here is 2 vector. A vector have a bigger length than V vector, but they have opposite direction. So that means the length of A vector and V vector may not be same, but they are called unlike vectors, right? Students, discussing about coterminal vector, as you can here is a definition. Vectors are said to be coterminal vector if their terminal points are same. As you can see here, there is 3 vector: A vector, B vector, C vector have same terminal point. So this is called coterminal vector. Now discussing about reciprocal of a vector. Let A vector be a vector, then reciprocal of a vector is a vector whose direction is same and magnitude is 1 by A upon rho magnitude. It is denoted as 1 by A vector or A vector inverse. For example, let A vector is equal to 2n towards south, then A vector inverse is equals to half of n towards south, right? Okay, students. Now students, discussing about free vectors. If a vector is depends only on magnitude and direction and independent if its position, then the vector. Student, discussing about free vectors. Here is the definition. If a vector is depends only on magnitude and direction and independent of its position, then the vector is called free vectors. That means, for example, here is a vector of AB with the magnitude 5 centimeter. If I move this vector AB from this place to this place, then the magnitude and direction will not change. That means this vector is called free vector. Okay, here I have written here, let the vector AB with magnitude 5 centimeter directed towards east. If we change its position, then we will get the same magnitude and the same direction. Okay, so here I have done some examples. Here is a question, right? In the given figure, which of the vectors are equal, co-initial and collinear? As you can see here, there is a figure. The equal vectors are A vector and C vector. A vector and C vectors are equal, right? Co-initial vector. So what is co-initial vector? So the vector which has the same point. That means here is a point, here is a starting point, and from this point here we have c vector, d vector and v vector. So this is called co-initial vector, v vector, c vector and d vector, right? Then collinear vector, the collinear vector are a vector, c vector and d vector. That means the vectors are collinear here, a vector and c vector, d vector. I have done this from the definition of these three vectors. Okay, so students,